Long ago, space was different. Imagine a vast, dark ocean, cold, empty, and silent. This was billions of years before Earth, before our sun even existed. No friendly sunshine warmed this place, just an immense, starless expanse. The universe held its breath, waiting, a canvas awaiting its first strokes, a grand cosmic story yet to unfold. No planets journeyed through this void. No moons danced around them. The familiar sights of our night sky were absent. Just the faintest glow from distant, ancient galaxies. A chilling emptiness pervaded everything. It was a time of profound darkness, a universe in its infancy, waiting for stars like ours to be born. Think about this cosmic loneliness. Our solar system was not even a dream. The elements that make us were scattered. They were stardust waiting for a call. This was the state of our local universe, a quiet corner of the Milky Way galaxy, unlit by the star we call the sun. Then, into this vast emptiness, something appeared. A colossal cloud drifted through space. This was a giant molecular cloud, immense beyond easy imagination, far larger than our entire solar system would be. It was a cold, dark, and diffuse structure, a cosmic nursery for future stars, and future planets too. This cloud was a reservoir of material, a collection of gas and dust, spread thinly across light-years of space. Its temperature was incredibly low, just a few degrees above absolute zero, so cold that molecules could form. Hydrogen molecules were abundant. H2, two hydrogen atoms bound together. This gas was the cloud's main ingredient. A shadowy giant in the galactic neighborhood. Helium was also plentiful. The second simplest element, also from the Big Bang. These two gases made up almost all the cloud, but there was more than just gas. For eons, this giant molecular cloud drifted. It remained relatively stable, a delicate balance of forces. Its own weak gravity tried to pull it inward, but the slight warmth and motion of its gas pushed outward. So it stayed a diffuse, sprawling entity, a sleeping giant in the cosmic dark, waiting for something to disturb its slumber. A cosmic alarm clock, if you will. Then, a cataclysmic event occurred nearby. A massive star, much larger than our sun, reached its end. It exploded in a brilliant supernova, one of the most violent events in the universe. For a brief time, it outshone entire galaxies. This stellar death rattle was not just a light show. It unleashed a tremendous blast wave. A shockwave of energy and matter, expanding rapidly through space, heading straight for our molecular cloud. This powerful shockwave was a game-changer. It slammed into the unsuspecting molecular cloud. Like a cosmic bulldozer, it plowed through. The shockwave compressed parts of the cloud, squeezing the gas and dust together. Imagine ripples spreading on a pond, but in 3 dimensions. With gravity now in charge, things changed. The denser clumps within the cloud began to collapse. Matter flowed inwards, drawn by mutual attraction. This was not a gentle, slow process indefinitely. It started slowly, then accelerated. The heart of each collapsing clump grew denser and hotter as potential energy turned to heat. These were the initial stages of star formation. Our own sun began this way, a tiny part of a vast, collapsing cloud. As these clumps of gas and dust collapsed, they spun. Why did they spin? Conservation of angular momentum. Think of an ice skater pulling her arms in. She spins faster and faster. The cloud or a clump within it does the same. Any slight initial rotation is amplified. As it shrinks, its spin rate increases dramatically. This is a fundamental law of physics, playing out on a cosmic scale. The collapsing cloud became a spinning vortex. This rapid spinning had another crucial effect. It prevented the cloud from collapsing directly into a ball. Instead, the material flattened out. Imagine spinning pizza dough in the air. It spreads out into a flat disk. The same happened with our collapsing cloud clump. Our young solar system was now a swirling disk, a vast expanse of gas and dust, orbiting a central glowing protostar. This protostar was our sun, but not as we know it. It was a hot, compressed ball of hydrogen and helium, shining fiercely from the energy of its ongoing collapse. But the fires of nuclear fusion had not yet ignited. Its core was still heating up, approaching the critical temperature for fusion. The solar system held its breath. The protoplanetary disk was a chaotic place, not a serene, orderly system of planets. Dust grains began to stick together. Tiny ice crystals and rocky particles collided, forming slightly larger clumps. These clumps, called planetesimals, grew over time, sweeping up more material in their paths. It was a cosmic construction zone, full of collisions, mergers, and near misses. The raw beginnings of future planets. This period was one of intense activity. The protostar at the center blazed. Its radiation and stellar wind pushed lighter gases outwards. Heavier, rockier materials could remain closer. This started to sort the ingredients in the disk.